Alrighty, so here we have the store instruction. The store instruction is a little weird. It does the same address calculation as the load instruction, and so in fact the data paths that compute the address work just the same as they do for the load instruction. So what's being sent on address wires is the sum of the contents of register A plus the sign extended constant. However, the data that's being written back into the main memory comes from the WRC register. So typically this specified a destination, this field of the instruction specified a destination. In other words, where we're going to write into the register file. But in the case of the store instruction, okay, this is sort of a little messy, but it gets the job done. We reuse that field to indicate what register is supplying the data to be stored into memory. And we don't actually have a way, at least on the previous diagrams, of reading the contents of register C. That particular field was being sent to the write address of the register file. In the case of a store instruction, we're using the RA field, but we're not using the RB field because we're using the B cell as 1. We're using the constant. So we're going to repurpose the second port of the register file, the one that was usually read at register B, which we're not using for this instruction. And instead we're going to say, look, for the store instruction, instead of routing the RB field to the second read address port, we're going to route the RC field. So in this case, RA2 cell, which is the control signal for this new mux up at the top here, says either select the RB field or the RC field as the read address for the second register. And then when RA2 cell is 1, we select the RC field, so the contents of register C comes out of RD2, and that's what's sent down here to the read data, to the write data on memory. Everybody sort of happy with that? The WR signal here, this is a write enable for main memory, very much the same way that WRF was the write enable for the register file. The WR signal is the read-write line for main memory. It tells with the memory whether it should only be reading or whether it should be reading, whether it should write at the end of the current cycle. Yes, questions? I saw some hands. I answered the question. Wow. Other questions? Yes?
So WR and WRF are complements of each other for the reason?
They're independent, right? One is controlling whether we're writing a value into the register file, and the second one is controlling whether we're writing a value into main memory.
But we don't want them to ever both be 1. In the sense that we don't want them to write things.
With the instruction set that we have now, we would never expect them both to be 1 at the same time. But that doesn't mean that we couldn't design some new instructions where somehow we were writing both into main memory and into the register file, or something strange. I mean, it's a little hard to see how that would work. But there's nothing at the hardware level that would prevent them both from being 1. It just turns out that with our instruction set, they're never both 1 at the same time.